I hope that works. Yep. All righty, ladies and gentlemen. 2.11. Boom. Okay. Logarithmic functions 2.11. Because logarithmic functions are inverses of exponentials, okay? Because they're inverses of exponentials, the characteristics of their graph will have inverse relationships. So when we had an exponential growth, right, exponential growth, which started low and did that, now we're going to have it look like, instead of it flattening out at the y-axis, it's going to flatten out at the x-axis. Okay? So exponential growth will end up looking something like this. And then exponential decays will start looking like this. All right? So here's what they want you to know about. A logarithmic function has the general form of y is equal to log base b of x, where b has to be greater than 0. B will never be negative. This is one of those things that I talked about. That base can't be negative because that really messes graphs up. It just bounces back and forth. It's really bad. Where a and b are constants, of course, a can't be 0, because if a was 0, then the whole thing's 0, and we don't even have a function. B can't be 1, because if b was 1, then it would be just a constant at 1, because 1 to any power is 1. So b won't be 1, b won't be negative, and a won't be 0, and that's all they're telling us right through there. It's understood, but a lot of times that confuses students, like, why are they telling me all that stuff? They're telling you that stuff because it has to happen. If it doesn't happen, then this is not a good function. The domain of all these actually now are the inverses of what the ones were. So the previous exponential growth, the range was from 0 to infinity. So now the domain is from 0 to infinity. 0 to infinity, provided it's not shifted left or right. Provided it's not shifted left or right. And now the range is from negative infinity to infinity, and that won't matter if it's shifted up or down, or expanded, or shrunk, or anything, because it's always going to be negative infinity to infinity. Okay? This is when a is greater than 0. It starts at 0 and goes up. And when a is less than 0, it starts at positive infinity down to negative infinity. Both of these, b is greater than 1, because b has to be greater than 1. So when a is greater than 0, it looks like this. When a is less than 0, it looks like this. This one's an exponential growth. That one's an exponential decay. Okay? Increasing versus decreasing. Logarithmic functions are always, are you not? There you are. Logarithmic functions are always increasing or always decreasing. Depends on if they're going uphill or downhill. They don't ever switch. Okay? If they're going uphill, they're just going uphill. If they're going downhill, they're going downhill. They have no maxes and mins unless they're restricted. What's up? So the graph on the left, that's a growth. Yep. It's the inverse of it. They have no maxes or mins unless if they're restricted domains. And if they're restricted domains, the min will be here and the max will be here. They're always concave up or always concave down. Okay. They're always concave down or always concave up. They don't ever change concavity. In behavior for logarithmic functions in general form, the input values increase without bound, the output values will decrease without bound. Since logarithmic functions have a restricted domain, they are vertically, wow, I've never seen asymptotic. They have a vertical asymptote at 0. As a result, the left end behavior will occur. This is something that's a little bit new to you guys, so make sure we somewhat recognize this. That's the left end behavior. You guys are used to seeing the left end behavior, the limit as x approaches negative infinity. Well, for logarithmics, they don't have x approaches negative infinity because their domain is restricted. So they will approach zero from the positive side, because you can't approach it from the negative side because there's no approaching zero from the negative side. So they will approach zero from the positive side. Again, provided this thing is not shifted left or right. If it's shifted left or right, it's going to approach that value from the positive side. So that's something a little bit new to you about the end behavior. End behavior limits. Limit as x approaches zero from the positive side will either be positive infinity or negative infinity. Depends on if it's that growth or that decay. And then the limit as x approaches positive infinity, that's the right. And that will either approach positive infinity or negative infinity. Depends on if it's a growth or decay. If this one's positive infinity, this one's negative infinity. If this one's negative infinity, this one's positive infinity. They're opposites. Okay, all that being said, hopefully you soak that up. Write the limit statements for the end behaviors of the following logarithmic functions. And they were nice to you on the left because they already put the left. The limit as x approaches zero from the positive side. That has to be the left, again, provided it's not shifted left or right, of f of x. So as I'm approaching zero from the positive side, I'm headed to negative infinity. The right limit as x approaches infinity of f of x, and as I'm approaching positive infinity, it looks like I'm approaching an asymptote, but I'm not. That thing's going up as it's going out. It's just going out a whole lot faster. So that will be positive infinity. If this one's negative, that one has to be positive. Okay, here they want me to write it. So let me move this up a little bit. Left limit x approaches zero from the positive side. And this one's h of x. And I can go ahead and write the right limit as x approaches infinity of h of x. All right, as I'm approaching zero from the positive side, that thing is shooting up to infinity. So here we have infinity. If this one's infinity, that one has to be negative infinity. But as I'm going out to negative infinity, that thing's going down. Again, it's not going down very fast, but it's going down. So when I get all the way out there to infinity, I'm at negative infinity. Okay. This last one, they did not draw me a graph. So you need to somewhat picture what this graph is. This graph is not shifted left or right. How do you know it's not shifted left or right? There would be a value what with the x, right? If it's with the x, and that shifts it left or right. Opposite of what you think. So this one's not. So we have a x, oops, sorry, gummit. Here, let's change to gray. So we have an x-axis and a y-axis. It's going to start at zero, but it's either going to start down here or up here. And that's all determined by what the value of, you can rewrite it exponentially. 3 to the y. I don't worry about the 2. All the 2 does is stretch it or compress it, right? So that's not going to change any domains. So 3 to the y equals x. And if you switch x and y now, right, 3 to the x equals y. So that's an exponential growth if you want to. Exponential growth, make it look like when this thing's out here at 0 right here, it gets flipped to this 0. Okay. And all that's because what, the 3 is greater than 1? If 3 was a fraction, then that would be the other one. It would look like the other one. So here we go, the limit. I need to erase some of that though, so it doesn't look bad. Limit as x approaches 0 from the positive side, and this one is g of x. is negative infinity, and the limit as x is approaching infinity of g of x. I apologize, my back's to like 90% of you guys. Breaking all kinds of rules as a teacher. I just can't teach from my desk. I just can't do it. Beautiful. If you get confused or something, and you should know this without a calculator, but of course, for your homework, if you want to, think about what you think it is, but if you want to verify, then just graph it. Or go to Desmos and graph it. Desmos graphs these a whole lot faster. You don't have it on your test, but it can help you with your homework. Think about what it is first. Increasing, decreasing, concave up, concave down. I think we've kind of somewhat beat this up. This one's decreasing. That one's increasing. This one's concave up. That one's concave down. When they give us the graph, it's easy. So it's concave up and it's decreasing. This one is concave down and it's increasing. This has got a negative, so that flips it. Okay, that flips it over the x. Or, yeah, again, if you get confused over this, if I divide both sides by a negative, I can do that. That would make this a positive, and that would make this a negative. So what were positive y's are now negative y's. What were negative y's are now positive y's, and that's how I realize that it flips it over the x-axis. Sometimes I get a little confused over which way it gets flipped. Okay, so if that flips it over the x, it's now no longer a regular one. It's going to be one that does this. So this one's decreasing, concave up. You can plug and chug values also. Okay, beautiful. I think I did that right. I thought these were easy except for one of them. Find the values of k that make it a constant. This goes 1, 2, 3, 4, 5. This goes 1, 2, k, 8, 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And I don't know if it's an easy way or a hard way. I think that's the easy way. I don't know. Divide by 2, add 1. Or instead of divide by 2, how about this? Multiply it by 1/2. Either way. You don't want a naked answer. This one starts with K. 0, 5, 5, 10, 10, 15, 15, 20, plus 5. K 6, 6, 18, 18, 54, 54, 162. Multiplied by 3. If it's multiplied by 3, then K has to be 2. Yay? I'm not too sure how you figure out the third one. Down 10, down 10, down 10, down 10. I can do that. This goes up 1. So you're trying to multiply, right? Say again? Plus 1, plus 2, plus 4, plus 8. Anybody else see that? I didn't see that one. It has to do with squaring, and it's shifted. Yep. It's the powers of 2, yep. How do you know that without knowing that? Y'all hear my issue on that? There's math behind this, but I think the math is harder than trying to guess and check. What did we decide this was? 11. This one's easy. Plus 4, plus 4. I'm sorry, plus 7. Jiminy Christmas. Plus 7, plus 7. I got like no sleep last night, so I'm doing all right. But I got home at, I don't know, 12:30, 1. This goes from -2 to 1. This goes from 7 to 10. -2 to 1 is 3. 3 to 4 is 3. 4 to 7 is 3. 7 to 10 is 3. So K is e to the 4th. Not 4, e to the 4th. Ah. Last 4, hopefully easy. Find the domain and the range. Domain and range, and all these are logs. So the range is easy for every single one of these because I don't care if it's shifted up, down, left, right. Oh, let me say, I'm sorry. Up, down, shifted up, down, stretched, compresses, whatever. Every one of these ranges, I'm sorry. Yes, every one of these ranges is negative infinity to infinity because they're the opposite of the domain. So every one of these ranges is negative infinity to infinity. Doesn't matter if we're up, down, left. I keep saying left, right. Up, down, stretched, compressed. We don't say stretched or compressed. What do we say? Say again? Dilated. Sorry. Thank you. Thank you. We're kind of nice. We don't have to say stretched or compressed. We just say dilated, which is better because it was hard for me to say it compressed by a factor of 1/2 because 1/2 tells me it compressed. So really, you kind of like double negative that thing. Domain, this one goes from 0 to infinity. Most domains go from 0 to infinity. B does not go from 0 to infinity because that thing is shifted to the right 3 units. So this one will go from 3 to infinity. It will go from 3 to infinity because it's shifted to the right 3 units. And that one is shifted to the left 3 units. It's not shifted negative 3/2, is it? I think it's left 3. We may have to fix some of this on Monday. All we're doing is introducing you to these graphs. We're not doing a whole lot to them. Yep. You do think it's 3/2 because you got to take the 2 out? Who's got Desmos up real quick? Chucky, you got Desmos open? 8 log parentheses 2x plus 3. I don't care if the 8's there or not, really. Hurry, Chucky, we're waiting on you. Where's the vertical asymptote at -3? Is it negative 3 halves? Fix it. Shh, fix it. Fix it. I should have factored that 2 out. So this is 8 log 2 x plus 3 halves. I factored that 2 out. You can't have that 2. You just have to do it this way. And so now that thing is shifted to the left 3 halves. To infinity. Dang, that's what I thought. The more I thought about that, I thought you had to.